This is another problem from your lab assignment, section 2.6. It says here we want to consider the following function, and we're going to look for things like the domain, the intercept, the asymptotes, and any additional points needed to plot. So let's go ahead and get started. First, find the domain of the function. So we want to factor the function as much as we can. It looks like the numerator might factor. Maybe a 7 and a 5 would multiply to 35, and then if we add -7 plus 5, it would get -2. The denominator is a difference of two squares, so x and 8. 8 squared is 64, so this would be a plus and minus. So if we can factor as much as we can consider things that we might be able to cancel and stuff. Alright, since g is a rational function, the domain of g includes real numbers except values that make the denominator equal to 0. And so at what values is the denominator equal to 0? So it looks like a list of positive and -8. So the denominator is equal to 0 with -8. And then it looks like, whoops, let's try that again. So -8, and then I need to put a comma here on +8. Use the answer you select to select the correct domain. So it's going to be everything except for these two values. Now that we have the domain, let's take a look at the intercepts. And for the intercepts, we're going to consider the x and y intercepts. So let's first identify the y-intercept. That's the easy one, I think. And we do that by setting your x equal to 0. So let's go back at our function, take a look at it, and when x is equal to 0, we get -35 as 0 minus 0 minus 35 in the numerator, and 0 minus 64. So it looks like it's just going to be 35 divided by 64, positive. So your x is going to be 0 because they want a point here. It looks like an xy point. And then the y value is your intercept. And so that is 35 divided by 64. After we get rid of the negatives and everything else. Okay, now that we have that, let's take a look at finding the x-intercepts. X-intercepts determined when the numerator is equal to 0. So we have the factored form up here, and the numerator is equal to 0 when x is equal to +7. So this is x minus 7 equal to 0, so we solve for that, x equals +7. And here we get x plus 5 is equal to 0, so it would be x is equal to -5. So with a smaller value, our x is going to be -5. And again, they want us to find the xy point, so we found this by setting y equal to 0. So our y is equal to 0, and then our second value is 7 and in the x, and then our intercept is when y is equal to 0, so that's going to be 0. So now we have the y-intercepts and x-intercepts. Intercepts are done. Let's find vertical and horizontal asymptotes. So vertical asymptotes are the easier ones to deal with first. We're going to find that for all the x values that make the denominator equal to 0. So we found the denominator is equal to 0 when we were looking at when we factored it. So the denominator is equal to 0 at + and -8. So vertical asymptotes, what are the equations of the vertical asymptotes? Enter your answer as a comma separated list of equations. So I think we have y equals to -8, and then we'll put a comma and put on our second equation y equals a positive 8. And that should be our asymptotes. Oops. They're vertical asymptotes, so they are x values. Not x values, but the x variable. So x is equal to negative 8, x is equal to positive 8. All right, that's better. Now to find the horizontal asymptote, if any, you do this by finding the ratio of the degree of the polynomials and the degree of the polynomial in the numerator and the denominator. And then here's the story again. If the ratio is less than 1, that's to say that if the degree on the denominator is larger than the degree of the numerator, then your horizontal asymptote is going to be 0. If the degrees are the same, then the horizontal asymptote is going to be determined by the leading coefficients of the numerator and the denominator. And if the degree on top is larger than the degree in the bottom, then we have no horizontal asymptote. So let's look at the degrees. The degrees x squared for both of them, and so they would have a horizontal asymptote, and the horizontal asymptote would be the coefficient, the leading coefficient, so the coefficient of the x squared on top and the x squared on the bottom. So there's no number there, we assume that it's 1 over 1. So it looks like the coefficient is going to be 1. Now we want to enter our equations. Actually, we only have one equation, and that is the y equals 1 equation is going to be our only horizontal asymptote going to positive and negative infinity. All right, so we should get a good idea of the picture of the graph based on what we have here so far. We know that it's the domain is going to be everything except for negative 8 and 8, and in fact negative 8 and 8, x equals negative 8 and x equals positive 8 are vertical asymptotes. We know the y-intercept, there's only one y-intercept. There should only be one y-intercept because it's a function. Think about that. And then there are two x-intercepts. So this graph is going to cross the x-axis at negative 5 and at positive 7. And then we have the vertical asymptotes and the horizontal asymptote is 1. Okay, so now let's figure out the rest of the points that we need to get here. And for this, we want to work around the points really that are around the x, the vertical asymptotes and the x-intercepts. So I'd probably want to choose a number that's less than negative 8. I'd probably want to choose a number between negative 8 and negative 5, and then a number between negative 5 and 7, and a number between 7 and 8, and just so to get some ideas of how these things might look like. Here they're choosing a set of different numbers, so let's go ahead and do that. So for this, we're going to take out our calculators and punch in some numbers. And I typed in the equation on my sheet here so I can see the numbers as I'm punching it in. Negative 11, x is equal to negative 11. So the numerator is going to be, it looks like it's going to be 11 squared, that's 121. And then 2 times negative 11 is positive 22. And then we have a minus 35. So it's going to be a 108. So this is 108. That's a numerator. We're going to divide by 121 minus 64. So 121 minus 64 is 57. I don't know if they're going to simplify, enter a fraction, do not approximate. So we'll just leave it like that. Now let's put in negative 9. So negative 9 in the numerator. So 9 squared is 81. Negative 2 times negative 9 is positive 18. So we're going to add 18 to that. And then we're going to subtract 35. And that's a 64. And then 81, positive 81 minus 64. So 81 minus 64 is 17. And again, I don't think that's going to cancel. All right, negative 7 in there. So the first number is going to be 49. This is a negative 7. So negative 2 times negative 7 is going to be positive 14. And then minus 35. So that's 28. In the numerator, 7 is 49. 49 minus 64 is going to give us a negative 15. So I'm going to put the negative in front here. So negative 28 over 15. Nope, doesn't reduce. We found this one by finding the y-intercept and putting zeros in for x. So that's 35 over 64. And then now let's put positive numbers. Positive 7. So we'll start off with a positive 7 squared. Let's try that again. That's a 49. Minus 2 times 7 minus 35. So that looks like it's a 0. Well, of course it was a 0 because it was one of our x-intercepts. Positive 9 in there. We're going to get 81 minus 18 and minus 35 for the numerator. So that's a 28, positive 28 divided by, and then let's put a 9 in the denominator. I think that's the same thing that we got before. It's 81 minus 64. 81 minus 64. It's a 17. And then putting in a positive 11, we're going to get 121 minus 22 minus 35 is positive 64. And then in the denominator, 121 minus 64 is 57. Okay, so those are our values. Again, the more important part is checking to make sure they're positive and negative, because once you're drawing the graph, then you can kind of see these graphs pop up. All right, so select the correct graph depending on your table. 35 over 64 is less than 1, so it's hard to see that, but we know that it's positive. We know also, based on our intercepts, that we're going to intersect the x-axis at negative 5 and positive 7, so negative 5 and positive 7. Here it looks like it intersects 0 and 0, so let's knock off these two graphs, the first one and the last one. So now it's a matter of trying to figure out where this is. And again, the y-intercept for this third graph is positive. The y-intercept for this second graph is negative. So if we again take a look at the y-intercept, it's a positive value, less than 1, but it's positive. So I would go with a positive graph over here. So I would select this one. And of course you can double check by plugging it into your Desmos or whatever graphing tool you have. And then that's it. So now we've completed it. So I hope that was helpful, and good luck.